All right, I think we're just about ready. I see the room filling up. It's always fun. There's this little counter. All the attendees are coming in. So welcome, welcome. This is the second of our Jetpack series from our droidCon online webinar. As you can see with me today, Ash Davies, Divya Jain, two of our speakers. In fact, from an earlier session, we had Divya doing a short talk, and we really wanted to have her back. She did her Camera X Lightning talk, and we at that point said we're definitely going to have Divya back to do something more. Ash, I think you did your first on refactoring legacy code with Kotlin, and we're happy to have you back on doing some navigation. So we are going to get started. Before we do that, I'm going to do a little bit of housekeeping. I hope everyone can see my screen. Let me just make sure that that's actually being shown. Yep, sure is. Okay. So if you're joining us for the first time, you will know that we use Slido for Q&A. So head over to slido.com. This is your code 31929. And what this will allow you to do is put your questions into Slido as the speakers are speaking. We have time for Q&A for everybody at the end, and at the end of each talk that you hear today. And so when you see a question, if it's the same one that you wanted to ask, or you think it's a particularly good question, make sure that you take a time to give it a thumbs up, vote on it, so that when Ash and Divya are ready to do Q&A, that they're being able to answer the most important and most voted on questions. So that's a good start. Also, throughout the webinar, Uli will send a unique URL that will take you directly to this. You should find it in your chat window. If you look on your GoToWebinar interface in your chat window, he'll also share a direct link for that. So, as usual, the videos from this and all of the webinars are at droidcon.com. Within a day or so, they're fully transcribed and searchable, and you can already go there and find everything. Of course, you can find the past talks from both Divya and Ash there at droidcon.com, but you can also find all the other videos from our webinar series and from droidcons that have happened.
Greg, we can't hear you.
Oh dear.
We seem to be having some audio issues there. I don't think Greg is realizing that. Greg, can you hear us? If you can hear us, we are not able to listen to you.
I think he's noticed.
Yeah.
All right. Have we got any audio now?
Yes.
Well,
You're
this
back.
is the first for us that we're having some technical difficulties. I'm not sure where I cut out for everybody.
You started looking up, and I think it looked like you were saying about some events that were coming up next.
So good, thanks, Ash. So we've got, as you can see, if my screen is still being shared, you can see that we've got June 18th and 25th, another webinar. And then, of course, our lineup for today, you can see we've got both Divya and Ash with us. Because I'm having, obviously, some weird technical problems with my microphone, I'm going to get the time turned over to Ash and Divya real quick. So, Ash, Divya, if you can turn off your screen, I'm going to make Ash our moderator here, and I'm going to let him fire away at this here. So let's get this, Ash, over to you. Let's see here. Okay, and Ash, you should be able to share your screen as well pretty quick.
Nope. Yep. Screen 2. And okay, can you see my slide?
I can see your slide now. Glad to see that this is the slide. I think in July in Berlin, there was some confusion early on whether you were giving this talk or whether you were going to be talking about cheese, if I remember. But this is great. If you want to, you could do both. I'm not sure if the audience is prepared to ask a lot of questions about cheese, but I do seem to remember there was quite a bit of expertise on your end on this subject. But this is good. This is a great topic. We're happy to have you because, you know, navigating from screen to screen is one of those important aspects. It's a fundamental part of app building, but it can also be confusing. So we're really glad that you're here to talk about this. So I'm going to click away, and the time is yours. Okay.
Awesome. Thanks, Greg. And thank you, everybody, for logging on tonight. I hope I get to get you interested in this topic. And if there is an occasional slide on cheese, I feel I have to explain myself now. This was from droidCon Berlin, where we had a sort of improv session thing. And one of my topics was, well, the topic I was given was cheese. It was quite difficult to come up with improvisation. So I ended up then repurposing my talk to then cover a lot of topics of cheese because I felt I had to make that up. It was very entertaining, but you might not understand if you have that context. Anyway, so let's move on to the topic at hand. So this is a talk on the navigation library from Jetpack. And it's sort of my experience coming from a situation where I would absolutely hate fragments. Anytime I would join a new project and there were fragments in use, I would automatically convert them to activities and I would just annihilate them on site due to obviously the often disliked methods in fragments and the very confusing life cycle and a lot of the confusion things that's going on here. But then after adopting the Jetpack library navigation library, I felt that actually they had a renewed purpose, and their original purpose actually then I went back to look at, and well, actually it was a really interesting journey and it was a really interesting experience. So I'd like to share that with you today. So yeah, comes from my skepticism on fragments and generally everyone's dislike of fragments. So let's start. So what are we trying to solve here? What problem are we trying to solve? So navigation is hard. And it's probably a bit of a misnomer to start a talk on navigation by saying navigation is hard. You're obviously all aware of that. That's why you're here looking at a talk about navigation. But it's often a topic of confusion, and it's like really difficult amongst new developers who are trying to get used to the Android framework, or if they're even just coming from another framework. And it's such a simple concept, really. You wouldn't think it should be something difficult. You are basically navigating from one screen to the next. And this sort of user flow should be intrinsic to your application journey and your user experience. So this fundamental behavior shouldn't be hard, right? So why exactly is this hard? You know, we're just moving from one activity to the next. What makes navigation so confusing? Well, it sort of comes down to Android's framework components. And they are things like activities, content providers, services, broadcast receivers, fragments, anything that is controlled by the Android framework. And this is because of having to handle configuration change or orientation change. This is where you might rotate the device, or the keyboard comes into play, or you split screen, or any of these nice foldable devices that are coming out now. And this means that the Android subsystem has to actually completely tear down your instance and then recreate it. So you have to have a mechanism of restoring state, and it has to have a mechanism where the actual infrastructure itself can control the orchestration of these individual elements. So it's not actually you navigating, it's Android, and you are just passing off the command or the instruction to Android to then do so. So in its simplest form, you might have an activity that looks like this. You might create an intent. An intent says, I want to go to this next activity, and then you pass this intent to the Android system. Now here you can see it might look a bit straightforward at first, but actually there's this is not going to scale very well at all. So for a start, we've got the serialization of additional parameters where the name or the key is being used from another activity. So then you've got this activity that knows about the next one, and the next one that knows about the previous one, and who is responsible for serialization of the parameters, who is responsible for deserialization, how can you guarantee that the next screen will have the necessary arguments that it needs to show the information. So it's really difficult to maintain this, and especially so when your application starts growing in size. Now, this is sort of kind of bred from the fact that the Android toolkit team don't necessarily have a strong opinion about how you architect or build your application. There's a really well-known quote from Diane Hackborn in 2016, back when Google Plus was a thing, that once you've gotten to the entry point of your activity, of your UI, sorry, we really don't care how you organize the flow inside. And this meant that we had a lot of different things popping up, like Mortar and Flow, and having custom views and having custom things that would actually sort of architect their own architecture because, well, they didn't like fragments. But let's just jump back and look at fragments. So introduced in Honeycomb API version 14, fragments were intended to sort of break up the screen into individual, more richer interactive user interfaces. And this is sort of the beginning of design-oriented thinking from Google on Android. It was really like a stepping point. And you can think about the original tablet layout where you had the master detail interface. Sorry, I'm trying not to use the word master. The main and detail interface. And this would have like a responsive layout for larger screens. So the idea would be that if you had this layout for your tablet, it would safely change into that of the mobile screen. So on the mobile screen, you might have a list, whereas the tablet, you have a detail of the list that you're seeing on the side. And this was a nice idea because it meant that you have the same layout, the same idea, the same user experience, and then a different screen factor. But the implementation, of course, as per usual, wasn't quite what we had expected, and the promise was a little bit oversold. It was promised to also run properly on smaller screen devices, but not necessarily always would. So this is how you might use a fragment in a simple activity. This is just a sample from the Android source code, from the Android documentation. It's not yet using Kotlin, it's just using Java. Sort of intentional to show you how verbose it is, but here you can see where the fragments are being created, the arguments are being assigned to it, and then it's being added to a transaction. Now, this is necessary for all sorts of reasons because you had to have the flexibility of how to use fragments, whether to have them retained, whether to have multiple transactions, and there's this crossover in life cycle where the activity might be in a different state that the fragment expects. So you have to have maybe commit allowing state loss or something. Furthermore, you have an issue where if your fragment is retained, or if it's actually you've not got it set up correctly, you'll actually end up having it doubly created. So you don't want to actually do anything if the saved instance state is not actually null. If the saved instance state is null, this is representation of our previous state that came before the configuration change. So if this is not null, we know that the activity has already been created. We just need to react to the orientation change. So yeah, as I mentioned, it's important to remember that the activity lifecycle is not the same as the fragment lifecycle. And furthermore, the fragment lifecycle is not the same as the view lifecycle. So we have three sets of lifecycles, and we have to then think about how they interact with each other. Now, this is really great cheat sheets from Jose, I cannot pronounce his surname, Ajedika, I would try again, where you can see how the fragment will interact with its activity based upon its intention. So, if you have a retained fragment against a non-retained fragment, you can see the differences in which methods are being called. So it's a nice little bit of information here, but the point is that the lifecycle is difficult to manage when you have multiple overlapping life cycles. And it can be a little bit quite hard as well when you're actually using the backstack if you want to go if you're going in particular directions. You might have to explicitly invoke add to backstack if you're manually handling transactions, and it's very easy to mess up your backstack if you're not doing it correctly. Usually when I'm giving this talk on stage, I would ask people if they recognize this sequence of directions. That is, of course, from the Konami cheat code, which is supposed to be an Easter egg, but it seems a bit obvious right now. There's more complications to this when you add things like the support fragment manager and the child fragment manager. The support fragment manager was meant to replace the original fragment management, but then moved it to the support library, which you could package inside your app instead of waiting for the framework to update it. But then you have child fragment manager if you want to use a nested view pager inside of a fragment, because the former can leak context if used inside fragments. I wouldn't expect anybody to know this, and these are the sort of gotchas that can really trip people up. So, you can understand why people dislike fragments so much. And furthermore, the communication between fragments can be really difficult. A lot of people would then use like an event bus to have this funnel of information going between, but then you have to have like a handover between each one, and you have to then know the state of the fragment, if it's been attached, if the activity is resumed. Add to that the fact that we have to serialize and parcelize all of our data so that we can package everything into a bundle. Bundle can be considered something similar to a serialized file. It's a bundle of serialized data, but there are some limitations. It will only support some primitives and anything implementing the parsable interface. And the parsable interface, when you implement it, describes how you would serialize this as a representation in primitives. So that's not cool, not fun to do, and a real pain in the bum. So, what are the options we have? And well, we have, as of 1.10, you can use the fragment factory. Now, this is really nice kind of evolution because it allows you to actually provide a constructor in a fragment in a similar way to they have with view models and a view model factory. We can start to describe how we want to construct our fragments, even though we still have to delegate this responsibility to the Android subsystem. We can then instruct the Android subsystem on how to do these. So these are all pretty compelling arguments against fragments in general, and you can understand why people don't want to use them or would prefer using activities. And as I mentioned, there are options like Mortar and Flow, or there's a new library that Square is working on actually as an evolution of this. Sorry, I'm not sure if it's an evolution, but I know they are working on a new library that's going to be soon. And then of course you have Compose coming up soon as well. But there were some nice reasons to use fragments. Fragments did actually have a real purpose and a real benefit in some circumstances. Some of these were activity capabilities. Now, the problem with activity capabilities is that these were tied to API versions. So you'd need to wait for a new release of the framework before you could actually start using new features. And in a lot of cases, even when used with compatibility, these features couldn't be backported. For example, the shared element transition in API 21. Now, this wasn't actually properly implemented using the app compat, but it provides shims, which are sort of like hacks that make sure that it fails gracefully. So it doesn't crash or it doesn't have any unexpected behavior, but it doesn't have the same shared element transition that you might actually like to have. So whilst compat shims are useful for ensuring app stability, it's not quite the same when what you're going for is a consistent user experience with nice transitions and beautiful graphics. So there was once a native Android fragment, which was however is deprecated in API 28, and fragments are now entirely in the Android X library. And this is great because we can update this inside our application so that the fragment sits within our application. We don't depend on any framework code, so we can use new features straight away. Another very nice feature of fragments is the ability for us to start scoping. Now, I noticed this problem when I was trying to build more complex and highly scaled dagger graphs, that you might want to have a repository scoped to something that lives longer than one screen, but doesn't live for the entire life cycle of the application, because maybe this only counts for 25% of your users, but for those 25% of your users, having cached data or throughout the user experience is actually quite positive. So there's a real need for having a scope that sits somewhere between a single activity and a single view. So as mentioned, sharing between activities is really difficult. You'd have to then you'd be forced to using an application, and there's nothing between an activity and an application that you can use or utilize to your advantage to group these things, except when you add children to an activity. So now we have fragments inside an activity that allows us to actually use the activity as this scope that we want to use. And now further with the nav graph, we can actually use a nav graph view model as a scope, which is fantastic, but I'm not going into that because this is an old presentation. So how exactly can we have our cake and eat it? We want to have all the benefits of fragments, but we don't want to suffer with any of the difficulties of using them. We're greedy, we're developers, we want it all. Well, introducing Jetpack. So of course, years ago, Google introduced Jetpack, which allows us to bootstrap Android development. The really nice thing is it sort of provides a lot of opinionated, clean implementations for common problems, because Google will never really wanting to get as opinionated as they are now, because it's up to us as developers. It was up to us as developers to sort of steer the direction of Android into the direction that we wanted it to be going in, and then Google would obviously work to help us with that. But the architectural decisions would generally have to come from us. But after years and years of the community begging Google for some guidelines, they came up with Jetpack to give us an idea about how to get started. It's important to remember that these are not golden rules that you must do these ways. These are simply suggested implementations. You don't have to use them. You can use some of them. You can use partial individual ones. It's entirely what makes sense to you, and you don't need to completely overhaul your application just because there's something new and shiny, even though I do. So what is Jetpack? Jetpack is a set of libraries. It's a plugin with Android Studio and some tooling used to unify and simplify Android navigation. And it handles all the common parts of navigation patterns and easily handling patterns like draw navigation or bottom navigation. It handles all the fragment transactions for you. All the up and back actions are handled correctly. The standardized transition resources, so you can then specify a unified approach to how fragments should come in and out of the screen. There's integration with deep linking and provisions for that. Excuse me. And there are easy navigation patterns to utilize. And finally, my most favorite part of this is type-safe arguments. So to understand why some of these things are quite so important, we have to know the principles of navigation. The principles of navigation are sort of a core set of consistent, intuitive user experience patterns. These are designed, and Jetpack navigation is designed to implement these principles by default. So you don't really have to worry about, is my app compliant to navigation UX? It just will be, which is fantastic. So you have things like the fixed start destination. This stipulates that the flow through your application should be consistent through both the entrance and the exit. So the user can reach a destination and then they can come back up through that same destination, and then the first and last screen pressing the back button. The state should exist as a stack, which is a complement to the previous slide. And it's a representation of a history that the user flow can be reversible and replayable. The idea is that your traversal through the application is similar to that of being in a browser. If you press the back button in a browser, it will do the same thing as it would do in your application. The up and back tasks are basically identical, with the exception of up never exiting your application. So if you reach the top level of navigation, there shouldn't be an up button. The up button will be usually in the toolbar at the top, sometimes combined with a navigation drawer. You won't want to have this on your first screen, but you would want to have a back button, and the back button would exit your application. And finally, that deep links simulate manual navigation. So if a user were to click a deep link from a marketing campaign or an email, or however you might share these links, it would have the same effect as if the user had actually manually navigated to that point. So then you can replay the going back if the user were to tap up or back. So these are really nice things. And the primary ideal of the navigation is to use existing APIs, not inaccessible ones, not APIs that are hidden from us. You might be aware of the .hide annotation that applies to a lot of Android classes that prevents us from using it, or at least make it more difficult. The idea here is that you could have written navigation yourself. Anybody of us could have done this, and then you could extend it. You can make changes to it. You can utilize it as much or as little as is necessary for your application, which is fantastic. So as mentioned, it's built from 3 components. This is the tooling. So Android Studio 3.3 introduces the navigation editor. We are actually, in fact, on Android Studio 4.0. So we've been using this for some time now, but it includes a graphical editor to build your application navigation graph. It's comprised of a few different components. First, the destinations to the left, showing the host in the graph hierarchy. Destinations can be anything really. They can be an activity, fragment, dialog, or custom view, and you can create your own destinations as you need. Secondly, you have a graph editor. This is a visual representation showing the flow of navigation through your application. And it's a really nice visual representation. And iOS developers might be familiar with the storyboarding approach, and this is something similar from this approach. And finally, you have the attributes, which are obviously attributes on each individual destinations that describe how this destination behaves in such ways. So if it has any arguments that are necessary for it to run, if it has any actions where it might go to the next screen, label, identifiers, various things like these. And if, like me, you would prefer to use XML layouts, XML, actually it's built in such a way that the XML is not actually so horrible to look at, and it's quite easy and straightforward. So you can actually write your own. And I much prefer to hand code in XML, even though the visual editor is also quite nice. So as I mentioned, you can have many different destination types. You can have activities, fragments, dialogues, and then you can define your own destinations as is necessary. If you do define your own destinations, you will have to extend navigator with your type, where T is the type. It could be a view or something similar. You provide the destination implementation, and you configure the arguments after inflation, and then you have to augment the nav controller. All of these things are basically providing a set of instructions to navigation about how you want this individual component created. Because you can think about how you might instantiate an activity, how you might instantiate a fragment, how you might instantiate a view. Each of these approaches is different, but if we want to have these as a unified destination, this creation behavior needs to be abstracted into the implementation of a navigator. So this is why you have to come up with it yourself, but as long as you're handling the backstack properly, it should be fine. But in most cases, you won't even need to, because fragments are enough. It's important to know as well that this is similar to sort of resource inflation, layout inflation, because navigation is an XML, your navigation graph is an XML document. So it's still subject to the same rules, like lint rules, compile time validation, resource names, and things like this. It inflates the resource at runtime, so there is a possibility, there is a potential for graph errors at runtime if you have bad references. Inflation cost is negligible; it's not really that much of an issue, but you can sometimes get some graph errors if you're in the wrong place. So what I quite like actually about this is that the nav host is not very forgiving when it comes to destination navigation. So if you find yourself in the wrong activity because of a misconfigured graph, and then you try and navigate somewhere else where you shouldn't be allowed, it will actually throw, giving you an idea that, I've probably done this wrong. So the fragment widget actually acts as the host for this. I've noticed my first incorrect slide. So this has actually been changed to the fragment container view, I believe. But this is actually still functional. I think it comes up with a lint error now in Android Studio, so you'll be able to see that. But once you've set up your nav host fragment, this is basically where all of the controlling is going to happen. This is where the nav controller handles navigation between each one of your destinations. It's only compatible with fragments as for the nav host fragment, so you couldn't really use it easily with other ones, but you could still have navigation to and from activities if necessary. What's nice is the lifecycle and configuration and animations are handled automatically, and the hosts host all movement and screens. So each nav host has a controller that allows you to sort of invoke these actions. And this controller is a very simple interface that typically has a few navigate functions. And you can retrieve a nav controller from a few different ways. There are a few different extension functions which are provided to us, one on the fragment and on the view and on the activity. One thing to note is that if you're finding a nav controller from your activity, you have to provide the view ID of the nav host because the activity is then actually higher than your nav host. So it needs to do a little bit more, be a bit more aware of its surroundings. What's nice as well is that you can assign actions to directly to click listeners. You can actually create navigation click listener with an identifier, and then do that. So instead of having this find nav controller.navigate, you can simply just create listener and set that. Nice little way of doing it. So many of you might be aware of intent filters in Android manifests if you want to create deep links, or if you just want to handle well, intent filters. This is obviously a very enjoyable activity. I haven't spoken to a single developer that hasn't told me I really love creating these intent filters in Android manifest. It's one of our favorite things as developers. So what's nice about the navigation component is that it actually can generate deep link intent filters for you, which is really nice because as I'm not sure if the sarcasm came across there, you know, these things are quite arduous and tedious to build and design. So if you just link your graph in your manifest, then these things will actually be implemented for you. So you just have your deep link in your navigation graph, defined with the parameters that have to do this. There used to be a such time in which it had to match every parameter exactly, but that has since been resolved. So you can have optional parameters if necessary. You can have question parameters as well. I don't think there is a way of having like a catch-all. You have to actually name each parameter, which is a bit of a pain, but generally this is quite nice and it's solving a lot of problems for us. So optional args are available in 2.2.0, but I think this is moot as we are further along than that. So there are two ways of sort of invoking a deep link. You can do so with URL navigation. This is great for app links, and it's like a cooperative behavior where you give a link and then the system asks if something can handle it. And if you set up your navigation graph correctly, it'll say, yes, that's fine. And it'll go to where it should be. And then you have the other type, which is explicit links. And these are built to allow you to programmatically produce a pending intent. And then you can apply a pending intent to something like a notification or a widget or a view click listener. And it might like something like this, where you specify your graph, your destinations, you add your arguments, and then that creates a pending intent. You can execute the pending intent immediately, but I've not had much luck in doing so, as it does, well, the first time I was trying to use it just didn't make a lot of sense. Turns out I didn't actually use it. I didn't need a deep link explicitly. I could just use the URL. You can also use a nav controller, which will then already know about the host, so that's kind of skips that step. And then you can use that to start activities. So cool. There are lots of different navigation styles as well. I mentioned briefly earlier that it has support for bottom navigation and draw navigation. And these are quite common paradigms. So you have things like a toolbar where you might have a contextual variant if something is selected, or you have a bottom navigation drawer that is now since become enshrined in material design. And of course, you have the traditional navigation drawer, which is still historically relevant. So your configuration would basically be just calling setup with nav controller. Now there's a few extension functions available that make it a bit easier to kind of use this, but quite simply, if you had a simple toolbar, you would just say setup with nav controller, the controller, and the draw layout. As I mentioned, there's a few extension functions available where you can then tweak the commands necessary. I recommend checking out the source code for this actually, because it's really interesting and you can see how it delegates through the hierarchy of calling these different extension functions and how you can actually customize it for your own needs. And it all it comes from this app bar configuration class. Now this app bar configuration class describes the construction on how things should be built and has all the different information about it. Whereas if you're using it with a draw or collapsing toolbar or these things, then it sort of does these for you. But if you want to specify your own, like you may want a custom behavior, then you can do so. Like, so you want to define your own top level destinations. Maybe you don't want to show the back button in certain situations. It's set up for draw layout, which is fine. You can set up a fallback up listener. So if, for example, you need to have some default behavior, you can listen to some destination change listeners. And I know you can use this for any reason, really. I suppose you could have it for logging if you wanted to. Oh, I noticed I have a semicolon there. That's foolish. So it's not a closed API. Functionality can be modified or handled specifically as you need, and it's really extensible, and you can really kind of modify it as and when you need and implement your own custom behavior. What's important to remember as well is that in 99% of the situation, sorry, 99% of the time, you won't need to. Coming back to bundles, and this is probably one of my favorite parts of navigation, is actually this further plugin. Now, we still have to do serialization, but with the SafeArgs plugin, which is part of Navigation Jetpack, it will generate argument classes from your navigation graph, which will have all of the arguments necessary, that have all the destinations necessary, everything that is required to go from one screen to the next will be codified. And the best part about this is that the generated argument class is not only a Kotlin class, it's null safe and provides defaults. Sorry, it's 1 second, I have to close my door. Bit windy outside. You can only use primitives or parsable values, as always with bundles, but this makes it much, much easier when it generates the implementation for you. So the implementation might look like this. It might look like main fragments direction.main to view balance. And this is the name that you defined in your navigation graph, where you're saying the action from one destination to the next, and that's the call you're going to make. And this is the class. This is the thing that SafeArgs will generate. And of course, it won't generate properly if you misconfigure it. So this will break a compilation, not at runtime, which is great. So if we add like a new argument to the view, and then it will update the generated directions class to take an argument now. So now we've added the balance amount. The arg classes will update accordingly. So now we call this main to view balance, and we have to provide this parameter. And what's really nice is because this class is generated automatically for you, as soon as you change your navigation graph, it will then be reflected appropriately. And if you're calling it, and if you're calling it wrong, it simply won't compile, which is really nice, because otherwise, like previously before this, we might have to then check for the existence of a serialized parameter in an input stream. Or have nullable values, or have all these sorts of things where we could potentially just omit something and have something crash at runtime, which is obviously not a very good user experience. The generated class looks a little bit like this, and generated code is never going to be pretty, but generated code is always going to be consistent and reliable, and what's more, it can't be abused. There's no way of sort of changing this code afterwards. So there's no way you can sort of inject behavior and kind of violate any single responsibility principle in it, or kind of have these kind of anti-patterns that we want to try and avoid, which is really nice. So it's just nice having these things available automatically. And serialization has always been a pain, so this feels almost magical coming from a world where you have to do manual serialization. And yeah, so like we can guarantee that serialization will happen correctly, and importantly, deserialization will happen correctly as well. So when we retrieve the parameters, they're going to be in this kind of Kotlin type safe class. The nice thing about this is that it defines a single source of truth. This single source of truth is going to be gospel for your activities. It's not open to interpretation. It can't be modified. It sits isolated from both your caller and your receiver, and it is something that exists on its own, and as I mentioned, can't be modified. The nice, another thing about this as well is that you don't have to go all in with the navigation library to use SafeArgs. You can actually already start using SafeArgs if you only have activities. You can start using the plugin immediately, and then utilize these arguments with only activity destinations. You'll have to navigate yourself, since you won't be able to use the fragment nav host. But already having this nice argument class generated for you is a real benefit, and it is incredibly useful, and you can delete so much code. I've deleted thousands of lines after introducing this. It's really useful. So how could you migrate using the paging library? Well, carefully. As with any migration, we do so very, very carefully. Because it may be difficult if you're making heavy use of activities, and you probably already have various navigation paradigms in place in use. So sometimes you might find that they're not so compatible with each other. And you have to be sure that the benefit of migration is going to outweigh the cost here. I can, with reasonable certainty, tell you that it is. But this is a decision that you have to make with your own team and with your own project. I would definitely, absolutely recommend using safe-args for activity arguments if you do not wish to use the rest of Jetpack library. Sure, but safe-args is, for me, it feels like it's low costs, high benefit. I think it's really worthwhile investigating. So consider perhaps, let's go for an example. Consider the left to be an activity to display a list and the right to show the activity, to show the details of that list. And here, of course, we have the reference to cheese. You might recognize these screenshots from Chris Bain's cheese plate activity, cheese application from some time ago. A bit old now, but still funny. So you want to be able to kind of move behavior away from your activities. If you are already using good modularization patterns, this should already be this shouldn't be a problem for you. You shouldn't already have a lot of logic in your activities. So if you're not already using view models, make use of view models and move any behavior or responsibilities away from your activities into your view models, because it's much easier to move a view model from an activity to a fragment than it is to move a behavior from an activity to a fragment. And it's just good practice. So then you can create a new activity to host all of your fragments, and it can be just a frame layout, and it will later become host to navigation graph. And then you move your existing activity logic to your fragments. You change your fragment bindings to activity bindings, on create view to on creates. Make sure that you can utilize on view created once things have, if you need to have post view creation behavior. These are things that don't really exist in an activity because you just have a on create and that's it. But here with a fragment, you have extra things to be concerned about. And of course, you're using view lifecycle loader. As mentioned, if you're using view models extensively already, you shouldn't have much logic in your activity anyway. So moving these behaviors over to fragments should be trivial in most cases. And then you can initialize a fragment in the host activity, like so. It's no more difficult than just adding a fragment to your hosts. You're actually just using the old school fragment transaction here. And then you'll want to pass your arguments as necessary. Here we're creating some intent extras and put it on the cheese list fragment because cheese. And then you can create your navigation graph once you've got this sort of layout of operations. And your navigation graph might look like this. You have these two destinations, fragment 1 and fragment 2, cheese list fragment, cheese detail fragment. You'll want to create your navigation hosts, specifying the nav graph is this resource and that it is indeed the default nav host. The nice thing about this is when you specify the name navgraph and default nav hosts, again, noting that we shouldn't be using a lowercase fragment here, we should be using fragment container view, you won't have to do anything in your activity. So your activity becomes this really simple, dumb activity with just one layout. And now that we have, argument constructors for activities, you could simply have the layout in the parameter for app compat activity and have your activity defined in one line. Isn't that nice? So then you might want to add an action to navigate from one fragment to the next. I might want to add an argument saying the item ID. So here I'm saying I want to navigate to the details fragment, and the details fragment says I need an item ID to display the things I want to display. So your fragment might look like this. In your view created, that's just setting an adapter. Feel free to ignore this. And then the click callback is where you are listening to this obviously event, and you're navigating from the nav controller. And that's it. That's all you need to get started. You can get started using safe-args straight away. You can start migrating things away from your activities and your view models, start using fragments. In our application, it's a very large application, so we have not yet migrated fully to using the navigation library. but it's really straightforward to use the navigation library in individual modules or even just on individual screens, and then manage them interoperable with each other. It has great interoperability. They work really nicely with each other, and there's not really a reason to not check it out. Another thing to be aware of though, that a lot of developers question is the presence of activity result, or how to handle this. Since fragments do have an on activity result listener, if it was called from a fragment, it's a bit more tricky when you're working with an abstracted navigation pattern. Now, previously there was only a ticket that we had to star to get some attention, but the team have actually made progress on this and have introduced what they've called the saved state handle. Now, if you check the view on ViewCreated methods and you retrieve the current backstack entry from the nav controller, you can then listen to changes to this value. So once the new fragment calls the equivalent updated backstack entry and updates the value with this, you'll receive an update in this or the original fragment of the new data that has changed. And you can check out the documentation for that over at the Android developers documentation. I'll be showing the slides will be shared at the end as well, so you can check these out as well. There's also a mechanism using live data and event, also a recommendation from Jose. This allows you to safely communicate with your activities. Now, sometimes you can have a problem with fragments or even activities actually, where things have been destroyed and recreated after configuration change, and then they resubscribe to a stream of events from your view model. Now, of course, your view model would have been persisted through its configuration change, and that existing live data value will still be there. So once the fragment or activity has been recreated and then it resubscribes, receives the latest value again, which then says to navigate again. So you might end up in situations where you have two fragments being created when you only wanted one. And this is a mechanism of doing so, of guarding against that. What event will do is allow you to only consume the contents once, and then it would return null after that. There's a lot of arguments about this being not the best pattern or it being an anti-pattern. I would probably recommend the use of a single buffered channel from coroutines as an alternative to this. But this is also a really great approach. And the link is here to Jose's article on where he's explaining its benefits. We also have dynamic features, which dynamic features are installed at runtime, so you can reduce the APK size. This is really, really cool. And we're starting to see support after IDS, but it's still a bit early access. Deep links, SafeBox navigation editor in dynamic graphs, not yet supported, unfortunately, but there is more and more coming. I would really like to see SafeBox compatible with dynamic features, but I honestly have no idea how that would work. There's also a great talk from Ian Lake, the single activity from years ago, why, when, and how. I would very much recommend checking this out. And then actually kind of checking out the more recent talk from the Android Developer Summit last year, where he covers the content from the previous talk and then speaks about how they want to go in the future. And that is everything from me. Thank you very much, everybody.
Well, Ash, thank you so much again for being back with us today. Hopefully you can hear me.
Yep, I can hear you.
Had a little bit of weird audio problems today, so we've got quite a few questions queued up, and I'm just going to pop out here and let you get to those. We've got about 10 minutes, so make sure just please read the top question. Uli will click that away as soon as you've started answering, and we'll go from there.
Cool. Okay, so how does Jetpack navigation handle bottom navigation with potential multiple stacks? Also, are there docs on the correct way to handle back press with bottom navigation? In regard to the documentation on the correct way to handle back press, I would probably say this is similar to the principles of navigation. This is well documented on the navigation on the Jetpack website, where it says how up should behave. But I guess it's not necessarily on the implementation, it's more about the theoretical user experience. In terms of the bottom navigation, I'm not exactly sure how to implement it for your use case. but I do know that it is extensible, and you can provide your own options to customize your behavior as you need it. As I mentioned, the fragment library is built in such a way that it is extensible, and you can use as much or as little as you need. So you'll be able to always have your behavior that you need. Thanks for the question. Next question. In my activity, I have bottom navigation inside which there are my fragments. There are some fragments which shouldn't have bottom navigation. How to implement it? A lot of people using bottom navigation. So I'm not sure I understand the question properly. You have fragments inside your bottom navigation. I probably wouldn't include fragments there. Maybe that's not what you meant. But yeah, I'm sorry, I'm not sure I understand the question properly. Is this actually, rather than stumbling, please feel free to contact me on Twitter, and I'd be happy to have a further discussion about it, and I can maybe better understand where the information you'd like to know. Sorry, I couldn't answer that properly. I'll do my best to do that on Twitter. So next question. Oh, this just changed. Okay. Does everything should be on navigation? Sometimes we have a screen, maybe an activity that is independent from where it comes and has no navigation from it. Absolutely. Sorry, absolutely not. Sorry. You can use navigation as much or as little as you want. You do not have to change everything to be navigation. Of course, everything works nicely with each other when it is all on the same platform, on the same library. But there is absolutely nothing stopping you from having one screen, an activity somewhere, and then having that integrate with your navigation graph. Your navigation graph can still use your existing elements, and you could actually start using navigation today and just define your existing activities as destinations. So there's absolutely no restriction here. You should be able to do that without a problem. How does Jetpack navigation handle bottom navigation with fragments loaded using dynamic feature modules? Wow. I don't know. Good question. What I can tell you is that the team will have likely provided an option for this, but I think since dynamic features, there's a lot of complications, a lot of difficulties with how it sort of loads everything at runtime, that it makes it very difficult to use with these types of things. So you sort of have to, these dynamic features exist in isolation without the rest of the application really knowing about it. So I would probably hazard saying that this is maybe not possible or maybe not kind of, feasible in its current state. But I would have to look into that further. Thanks for the question. It's actually really good. But again, sorry. Does Jetpack navigation scale well with larger projects? Yes, it does. So I'm using navigation in my current project with Immobilian Scouts. Our project's been around for about 10 years. It is a humongous project. And whilst navigation is not used in all modules, I have navigation used in a lot of different ones with some very large navigation graphs. It is very scalable. In fact, that's actually one of the most important factors of it, is that it is scalable. Some of the really nice features actually started presenting themselves once people started using them from the entire application. This idea that you could use a single activity for the entire application meant that you would have to then have something in between a fragment and an activity if you needed some sort of store there. And that's why you can use your navigation graph as a store for your view model. So you can retrieve a view model from a navigation graph. Then since you can have nested navigation graphs, your entire application hierarchy is defined in a navigation graph. And at that point, the activity sort of becomes a bit redundant. So that's a really nice feature. So absolutely, it's definitely scalable. Next question. Navigation with back button and nav drawer. There are a lot of issues around them. Any resources for good implementation that takes care of all the cases? I think actually it should handle this out of the box. So if you set up your nav graph properly with a back button, sorry, with the navigation drawer, the back button should behave as appropriate, coming back through the hierarchy until it reaches the top and then exiting your application. as mentioned, the principles of navigation is obviously a good source of documentation for this, so you know how it should theoretically behave. But with regards to the implementation, I would, wherever possible, delegate this to the fragments library. Next question, it's possible to manage multiple navigation graphs in one app. If so, it gets merged when app is distributed like app bundles. Okay, yes, it is absolutely possible to manage multiple navigation graphs in one app. They are not merged as such. They are sort of contained. You have to remember that these are resources. So much like having a layout file or a drawable resource, these are going to be treated in the same way in that they're inflated at runtime. So you can define nested graphs, you can define graphs in one module and then have another module depend on that and then import that graph. And when that graph has been imported from the other module, it'd be as though you copy pasted it, and the behavior is exactly as you expect it should be. So this allows you to actually maintain this level of modularization in a well-architected app, while still benefiting from having things like safe arcs, well-documented navigation graph. Cool. Next question. I've experienced that going to another fragment makes a replace fragment by default. Is there a way to override and add instead of replace? I believe this is actually highlighted in an issue on the issue tracker for this library. And if memory serves, I think Ian had said that this was actually the intentional behavior. It would be possible to override your navigation. I think there was some other edge cases where people wanted like a transparent dialogue and you needed a sort of different behavior with the fragment. It is entirely possible just to copy paste the fragment navigator implementation and tweak it for your own purposes. It's a bit arduous to do that because it's not a small implementation, but that's how you would do that, or how you could do that. How to deep link to a fragment inside a fragmentception. Quite simply, actually. So it's important to remember that the navigation library treats every destination as a destination. It doesn't care whether it's an activity or a fragment or a view. So if you have defined your deep links in your navigation graph for one particular fragment and you provide that as a URL or as a pending intent to the user, then it's just going to handle it as expected. It doesn't matter whether you're in a fragment or in an activity. It will properly navigate from one to the other. So you shouldn't have problems with that one. Can we navigate to fragments in different Gradle modules, or do we need an activity in each module with a separate graph? Yeah, I touched on this one a little bit as well. You absolutely can. Navigation graphs can exist in different modules and you can navigate between them. You can import one navigation graph from one module into another one if you have the activity there. What you might find, however, is, as you mentioned with the activity per module, if there isn't a host to go to that lives in a higher domain as such, like if you don't have a single activity in your application module, in the root module, then you might need to have an activity per module just so there's like a landing activity. But if each one of these activities is really dumb, the further you get through the implementation and the migration to navigation, you'll find that it's really easy just to sort of collapse these over time, and you can then start moving towards this truly single activity. Cool. Can we navigate to fragments in different Gradle? Well, that was the same question, sorry. In the navigation editor, I get preview unavailable, even though I use tools.context in my layouts. Any idea why? I'm afraid it can be for any number of reasons, unfortunately. It could be a misconfigured graph. It could be just an unstable version of Android Studio. What I would recommend doing is probably make sure you're using the stable version of Android Studio, which as of this moment is 4.0, and then maybe try checking out the sample repositories from the Android samples GitHub repository, and then you can check out some nav graphs there, and then make sure that they appear properly in your IDE. Maybe you could copy paste them over and then try them in your projects, and see if they are showing in the layout editor, in the design view properly, and then sort of try and debug it through that. Just process of elimination, remove part by part.
Ash, let's have you answer one more question. I don't want to cut Divya short, but we want to make sure that we give her enough time. So let's do, you can choose any of these 4 that are there, choose your favorite question, and that'll be the last one for the day.
You know what, actually, I'm thanking you for this because I see we have another 13 questions. All right, so let me have a quick read of these next
They're all going to be posted to your private.
I'm going to go with Gavi's question, the third one, because this is actually quite interesting. Live data unchanged is called every time I come back to a fragment for a method called consider notify. Consider notify is the implementation that goes on behind the scenes in live data, and it's where it says, you know, consider notify checks if there are any subscribers on the live data and whether those are in the right lifecycle state, and then it decides on whether to then inform or call this on changed function in your live data. So that's just where it shows in the backstack. Now, the reason this is happening is because when you come back to your fragment, it is then being resumed. Maybe it was resumed after a configuration change, maybe you navigate from somewhere else, and then you're collecting these events from your view model. But the problem is that the view model was retained through the orientation change. So it's the same view model, and live data is a sort of data holder. So when your fragment then resubscribes to the live data on your view model, it will then receive the latest event. This is known as conflation. No, so yeah, kind of. And this means that it will receive the same indication that it should navigate again. So it will then try and navigate twice when probably not what you wanted to do. The best way to resolve this is you can wrap the data type of your live data inside the event. This is the event class that I mentioned in a few slides earlier. The links will be shared online, which makes sure that the event can only be consumed once. And then once it's consumed, it doesn't allow it to be consumed again, making sure that your fragment will only navigate once. You can use an alternative approach from coroutines where you have a channel with a buffer of 1 or a conflated channel, and then consume it as a flow. Make sure you use receive as flow, not consume as flow. Otherwise, the upstream channel will be terminated. So I hope that answers your questions, and I hope you've all enjoyed the presentation. Thank you.
Thanks, Ash, so much for being here. Really appreciate it. Last time, you know, we had the clapping app. I had an upgrade for you today, but I'm having such weird audio problems. I'm going to turn this over to Divya really quick, and we will a little bit. But as everyone can see in the chat, we posted a link to Ash's slides, also to his Twitter. So if you want to ask any of the rest of the
And we're gone again.
Greg, we can't hear you again.
Hi, Divya. I'm gonna make you present, and then you can start your presentation until Greg is back.
Awesome, sounds good.
I'm gonna hide my webcam now. Bye, everyone.
Yeah, thanks, Ash. Okay, hope you guys can see my screen.
We sure can. Sorry, I was dropped out again with the audio question. Yeah, you're good to great. You're good to go.
It sounds good. Okay. Let me just. Okay, hi everyone. I'm Divya Jain. I work with Game Time, which is a ticket selling platform in San Francisco, and I am big thanks to the droidCon online organizers for having me back. Also, a big thank you to everyone who's out there today, who's here, and I really hope that everybody is keeping safe and healthy. So let's get started. So today I'm going to talk about Work Manager, which is another Jetpack library, which acts as a super clever delegate for scheduling all your deferrable background tasks. So let's get started. Okay, so how many of you identify with this? Especially these days, we are all working remotely. So imagine being bombarded with multiple tasks at the same time, deadlines, no delegates, no assistants. I'm sure it sounds familiar, which is our everyday stories. This one here looks super energetic, but I'm sure at one point of time, like everybody else, it wears you out. And the reason that I started with this slide is because it is the same thing with the Android main thread. The Android main thread, as we all know, has lots of responsibilities. It handles all your UI events. It coordinates user interaction, also user events back and forth. Also, it responds and receives all your different lifecycle events. And we all know the golden rule of Android, which is basically if there are, it's a lot more limited resources. So which means that if you're doing a lot more things on the main thread, it leads to either a slow or a very hung up screen, or also the most dreaded application not responding alert. Also, there might be various criterias that if we want to perform a task, there might be various criterias that we need. For example, we might need the task to be performed immediately, or we might need some sort of completion while the user is interacting with the app for sure. So if the app shuts down, then we don't need the task anymore. Also, there might be a criteria where the service may need to be completed while the app is active or not. But there are other tasks like syncing, fetching something from the server, which is a very common functionality, or even when the app is not active. We also might want to schedule tasks for some particular time or for periodic intervals. And so anything which needs basically more than a few milliseconds, we need a background thread for it. Also, mobile devices has very limited resources. There is limited battery life, there is limited memory in general. So the idea is that we don't want to overload these resources with unnecessary consumption and instead be conservative with our approach. So now over the last few versions of Android releases, because of these, to overcome all these restrictions and these limited resources, a number of restrictions actually were introduced to ensure that the battery is optimized. There is elimination of unnecessary background processing and constraints on the already existing limited resources, but still provide a good user experience. And some of the examples are these restrictions which were introduced with different Android versions. For example, the Android 6 had this DOS mode and app standby, which started with restricting background jobs, network accesses, and syncs for apps that were not used or stationary, and also put unused applications in the similar restricted state. Then with Android 7 came the DOS on the go, which further applied restrictions to CPU or network operations when the device screen is off for a certain time and not plugged in. So even in your pocket, even with the device in your pocket, you're on the go. Then with Android 8 came the limited background behavior, which imposed limits on the background executions like services or broadcasts and collection of user location services in background. And also it periodically released cached wake locks. And then with Android 9 came the app standby buckets, which basically let the system prioritize the app request for the system resources based on how recently or frequently the app is used, which further helped with optimizations. So let's say we are implementing a background task in our own app. Now we have different solutions available for us at our disposal, which is something like download manager, multiple threads, alarm manager, services, job dispatcher, or even the scheduling of the jobs through the work manager. Now the idea with each of these solutions is that they have a specific capability or specialty which satisfies its own certain criteria that the task requires. So the question to ask here in order to choose the right solution for your background task is A, whether it is a big HTTP download. For example, you want to download big files. Then for that, we have the download manager, which will handle the necessary HTTP interactions. It handles the retries needed or handles the failures itself. Then if it is not an HTTP download, then the next question to ask is whether it is a deferrable task. So which means that if the task needs to be immediately completed, like in response to clicking of a button, or if it can be actually completed in some time, like the use case doesn't really care about the timing of the application, but it can be deferred to sometime in the future, which for example, we want logs to be uploaded or some fetching of the data in the background which we don't need immediately. So if it is deferrable, if it is a task which needs to be completed immediately, then we have a foreground service, because that is another way of telling the system that we need this task is the priority. But if no, then the next question, if the task is deferrable, then the next question to ask is if the task needs to be executed at a specific time, which is obviously the case of calendar events or the regular alarms that we have. So if it is a specific time oriented task, then we have the alarm manager. But if not, then if we have answered all these questions and we still come to this point, then we know that our solution is the work manager. Also, if the task is specific to a certain system conditions or dependent on specific constraints, for example, if you want it to be like if you want logs to be uploaded only when we are on Wi-Fi, or when the phone has enough battery, then for all these the answer to all these questions is work manager. So basically, reiterating, the basis for why you would want to choose work manager over any other solution is A, if the task is deferrable, B, if it requires specific sort of system conditions, there is no particular time associated with the task. We want the task to happen at some scheduled at some time, but it's not very specific. Also, the main criteria is that we want reliable execution, which means we even if the device if the app has exited or if the device has restarted for whatever reason, we still want the scheduled task to happen, then the answer is a work manager. So let's talk about work manager in detail. So as I mentioned before, it is part of the new Android Jetpack library. And the basic functionality is that it cleverly and reliably schedules deferrable asynchronous tasks when the system conditions that are specified are satisfied. So internally, Work Manager itself for API versions 23 or above leverages the job scheduler, and for the older APIs uses a combination of broadcast receiver, alarm managers to optimize this background processing. Or if it has access to Google Play services and GCM, then it uses the GCM Network Manager. Now, with the new Android 10 release, the Firebase Job Dispatcher and the GCM APIs, which were supported earlier, are not supported anymore. So, but there is an extensive migration guide on the official documents to officially move to Work Manager for all your scheduling of these kind of tasks. Now, the other features are that there are wide variety of constraints that can be specified. As I mentioned, only you want the task to be only carried out when it is on Wi-Fi, or the device needs to have sufficient storage, etc. And I'll be talking about all these in detail in some time. Then second is that it allows robust scheduling of jobs that can be named, that can be tagged. It can the user can monitor groups of work. And it also works well with the restrictions like doze mode that we talked about earlier. We also know that the task will reliably and for sure execute because the work details are actually persisted in an internal database, so which ensures that work details and states are persisted even if the device reboots for some reason or even if the user exits the app. Now, if the task fails once for some reason, Work Manager actually offers flexible retry policies, which we'll also talk about in some time. It also allows you to chain groups of tasks sequentially or parallelly, providing conditions, which gives you the flexibility again to schedule based on different use cases. So it over all these features, it has the ability to be used in combination with the new, other solutions like coroutines or RxJava in order to provide best optimization that is possible for all these background tasks. So now once we have already asked the questions and we know that Work Manager is the appropriate solution to schedule my background task, how do I get started with it? So obviously the first thing is add the Work Manager dependency onto your app, onto your project. Then create the task, configure the constraints which we want to specify for the task, and then hand the task to the system. So it's a simple 4-step process, and I'll talk about the details of each one of them. But starting with Work Manager it literally constitutes all these basic 4 steps, and the system then takes care of ensuring the optimization of how to schedule these tasks. So starting with the first one, which is adding the Work Manager to your Android project, basically add all these dependencies. And here you will see, as I mentioned, it is so robust that it actually provides you with the flexibility to work with coroutines, RxJava, GCM Network Manager support, and even writing your tests to ensure that the tasks are implemented in an efficient way. Now, the second, once we've added the dependencies, the second task is actually creating the background task, which involves further 3 steps: extending the worker class, overriding the do work method, and then finally getting the result. And here is a simple 3-line code for it. So we have an upload worker, which extends the worker class, overrides the do work method. So for example, if you want to sync to backend or upload images, this is where the logic for that will be implemented. And then finally it comes back with 3 kinds of results. It can be a success, it can be a result.failure, or it can be a result.retry, which, as I mentioned, allows you to retry the task in case it failed for whatever reason. Now, worker, as we mentioned in the previous slide, defines what task to perform. Now, there is another object called the work request, which defines the how and when, and also allows you to define the various constraints for the task to be executed. So let's talk about the when first. There are 2 types of interval tasks that can be scheduled. As it says, the one-time work request, which is basically non-repeating, and it is created by using this one-time work request object. And the second one is the periodic time work object, which allows you to specify the intervals. So here, for example, it is the task of uploading, syncing the images with the backend is scheduled for every 1 hour. So also another example can be periodically sending logs to server or backing up your data, etc. So this interval for periodic ones that is mentioned here is the minimum time between the tasks. But also if, for example, after an hour, if the constraints are not met or the system optimizations are not in place, then it can be further time before the task is repeated. Now, the minimum interval which can be defined is 15 minutes by default. And also, if the work, with the latest version of Work Manager, if the work is sensitive to when it needs to be run, there is an option to also configure a flex period or a flex interval basically inside these intervals. So the whole idea is to provide you with as much flexibility as possible, but at the same time making sure that the constraints are met and the optimizations are in place. Now let's talk about how to add multiple constraints. Now we have something called the constraints builder, which allows you to create a constraints object, and it already has a huge list of specific constraints that can be defined. For example, we can have a required network type of metered, or we need this task to be accomplished only when the phone is with charging. So this is the way that we can through the constraints.builder we specify different tasks and hand it off to the system. The work manager will execute the tasks only when all these constraints are met. And if a constraint fails during the task will be stopped, and the work manager will wait for the system to again meet all the constraints before executing again, if the specified policy is retry. So finally, we have created the worker task, defined the constraints, defined when to schedule the task for. The final step is hand the task off to the system. So work manager follows all the best practices for system optimization, again, to execute the scheduled task. So we basically schedule it using the NQ method, and work manager will handle all the optimization, but with the guarantee that the task will be executed when all the constraints are met. Now, how does the work manager internally execute? There is an internal task executor that handles all these enqueued requests. Now, what it does is it takes the work request info and saves it to the work manager database. Now, this database contains all the information and the statuses of each work request. For example, the current state, the input, outputs, constraints, etc. So now this is the thing that ensures the reliability that your work will be executed. So for example, if the user exits the app for some reason, or if the device restarts, the database acts as your cache where all the info is pulled out and the work is resumed or carried out again. Now, when the constraints for the particular work request are fulfilled, the executor tells the worker factory to create a background worker for the request, and then the default executor calls the do work method, which we specified earlier, of the worker to actually carry out the work off of the main thread in its own background thread. Now, also the work that is scheduled many times needs an input data. For example, if you're uploading logs, you actually need the logs to be uploaded, or for data to be backed up, or for images to be sent to the server, you need the image URI. Now, these input values are stored as key value pairs in something called a data object, which is then set on the work request through the send set input data method as shown here. Now, these data objects, one thing to remember about them is they should be small, and it also supports only primitive data types such as strings or any such array variants. And there is a maximum limit on the size of these objects, which is 10 KB. So if you need to, for some reason, specify bigger data, then you need that data needs to be stored somewhere in a local database and fetched every time you want that to be sent to the backend server, or to be passed as input to the workers. Now, also there might be times where you don't want to specify any constraints for the task, but you don't want the task to be scheduled or carried out immediately. So there is a method called the set initial delay, which basically allows the user to delay the initial task execution by a certain amount of time. And this can be set on the work request. And obviously this is possible only for the one-time work request. But if you specify this initial delay for a periodic work request, then only the first part of that periodic request starts with this initial delay. Now, if the work needs to be retried, there is as I mentioned, there is a return of the result.retry from the worker. Now, this allows us to set the backoff delay and also retry policy. Now, the combination of backoff delay and the policy determines the actual retry config. So backoff delay determines the minimum amount of time to wait before retrying the task execution. And the default is, I think, 30 seconds, if I'm not wrong. And the backoff policy defines how the delay is going to increase. For example, you can define it to be either linear or exponential over time for retry attempts. Now, also there is another feature which is available, which is called tagging of these tasks. Now, this allows you to operate on multiple tasks. So basically, you associate a tag with each of the tasks that you want to associate together. And then there is an easy method to identify all the tasks associated with a single tag. So for example, all tasks with the same tag can be canceled together using cancel all works by tag method. Or user can also get the status of all the same tasks that are tagged with the same tag with one request and observe the progress. So also that is possible by methods like get work infos by tag, etc. Now, every task that is carried out by the work manager goes through a life cycle and various states. So block state is possible in case of chained tasks that are chained together. And for example, the work enters the block state if a prerequisite work is not completed for some reason. Then enqueued is when all the constraints and the timings are met and the task is eligible to execute. Now, a task which is actively running is obviously in the running state, and then based on the result of the task, it either enters the succeeded or the failed state. And then for some reason, if the user explicitly canceled the task, then it enters the cancelled state. Now, the things to remember here is that the succeeded and the failed are terminal states. It can be only entered by one-time work request, because for periodic, it doesn't really make any sense. And also for the failed and the cancelled results, if one of the tasks is marked as failed or cancelled, then all the subsequent tasks which are dependent on this task through the chained reaction are also marked the same. Now, after the work is enqueued, you can also keep an eye on the status of the work through something called the work info object. Now, this work info object includes the ID, the tags, the current state, and also any output data which comes out of these tasks. They also have a corresponding live data version, which lets you observe the changes and then register a listener to respond to these changes. So basically, you can notify the user if the work has succeeded or failed based on this live data information, based on observing this live data information. Now, also with the latest Work Manager version, there is support for setting and observing intermediate progress of the work. So if the app is in the foreground while the work is being performed, the UI can observe this intermediate progress and allows the user to be more informed. Now, this progress is received through the data object which is very similar to the input-output key-value pairs. And so the work info we talked about also has another method called the get progress, which gives us the data in terms of live data, which we can again observe and keep notifying the user in case we need to of the intermediate progress. So the conclusion is that there are two methods available, which is the set progress and then get progress. The set progress is used to persist this progress to the database, which is also extensible to the Kotlin's coroutine worker object. And then get progress is used to react to intermediate progress information. Also, there are ways to retrieve this work info. As I mentioned, it can be through a work request ID. It can be through a work request get work info by tag. And it also lets you it allows you to specify a unique name, which I'll talk about in a second. So these are different ways to retrieve this work info and observe the changes or the progress of the task. Now, to execute tasks, we might have multiple tasks which needs to be executed in a particular order, or they need to be executed parallelly, and also might be dependent on the previous task completion. So Work Manager allows you to chain different tasks together. And for example, a good example of this is, for example, if you're trying to process different images. So you can process these images by scheduling parallel tasks together. And then only when we know that each of these tasks has completed, we want to upload them to the backend server, we can chain them as a subsequent task to upload them to the backend. So here we have a method which is, in order to chain different tasks, we have a method which is begin with, and then the list of method allows you to specify tasks which can be run in parallel with each other, and then consequently we can have then to have dependent work chained, which only runs after all the previous work in the chain has been completed. And again, going back to, so for example, if for some reason any of the parallel 1, 2, or 3 tasks fail or is cancelled, then all the tasks 2 and 3 will also be marked with the same status. Now, so also, so when these one-time tasks are chained together, the output of the previous task becomes the input to the next chained task automatically. Now, when the tasks are run parallel, it means that there are multiple outputs which needs to be merged to a single output for the next task. And this is possible through an input merger. Now, this input merger can be of 2 kinds. It can be either an overwriting one or an array creating one. Now, distinguishing between the two depends on how much data needs to be preserved, or if there is a flexibility enough that some data can be overwritten. So the overwriting one actually overwrites the keys in case of conflicts, which means that the task, the output can be actually overwritten, but the array creating one merges all the inputs and creates arrays if need be. So we can add, there is a method called set input merger, which allows you to specify the kind of conflict resolution that we want. Now, to ensure that only one chain of work is being run at one point, Work Manager also allows you to specify a unique human readable and developer specified name to a task. Now, this is different from the IDs because it is not auto-generated and it is actually developer specified. And it's also different from a tag because they're associated at one time only with one chain. Now, here you see so we can use the enqueue unique work method to basically ensure that this is a unique chain of tasks that is happening. Now, the existing work policy is what is used to specify how to handle conflicts. If we have a chain sequence with the same name, but that is already running but hasn't finished yet. So again, there is either replace, keep, or append, which is, as the name suggests, the replace one replaces the existing one. The keep ignores the new request but keeps the existing one. And the append one actually just appends it. So if the previous task with the same name has completed, then this one is carried out. Now, this unique naming is suitable for tasks that shouldn't be enqueued multiple times. For example, if you're already sending logs to the server, you don't want to schedule another batch. So you can either choose to ignore the existing ones if the previous one is still happening, or you might want to use the append policy to chain it to the existing one. Now, this unique naming is also useful when you want to gradually build up long chain of dependent tasks, but each task itself takes a significant time. So now when we want to chain tasks with a specific name, instead of using begin with, you use begin unique work with method. Now let's talk about canceling the tasks. Now under the hood, the work manager keeps checking the state of the work. If the work is already finished, nothing happens. But if the user decides to cancel the task, the state will change to cancelled and the work will not run in the future. Now, as I mentioned before, any work requests that are dependent on this work will also be cancelled. Now, if the work is currently running and the user decides to cancel the task for some reason, the work will also receive a call to a listenable worker.onStop method, and which allows the user, the developer, to override this method to handle any potential cleanups to avoid memory leak. Now, what can be the different reasons for stopping this work? Now, it can be either the user explicitly asked for it by calling the cancel work by ID method, Or in the case of unique work, it can be we explicitly include a new work request with the replace policy, so the old work will be cancelled. Or another reason can be that the work constraints are no longer met, or the system instructed your app to stop your work for some reason. Now, this can happen if you exceed the execution deadline. Each task generally in a work manager has an execution deadline of 10 minutes. So if the deadline is, if the task interval has increased, then this work is cancelled but scheduled for a retry at a later time. Also, so by default, when your app starts, the work manager configures itself automatically with default options. But with the latest version of Work Manager, it also gives you enough control to customize this configuration by using something called an on-demand initialization. So now, as the name suggests, with this kind of initialization, the Work Manager is created only when we need a task to be scheduled and not by default, which means that with every app restart, there is no Work Manager initialization, which means that there is an improved performance and the app starts with a lot more speed. So in order to incorporate this on-demand initialization, you can remove the default initialization from the manifest file, and the application class implements this configuration provider interface that you can see here, and then implements the get worker manager configuration method itself. So whenever you need Work Manager on demand, all that you need to do is call the Work Manager get instance, pass it the context, and the Work Manager is initialized on demand. Also, so as I mentioned before, a Work Manager's task limit at a time is 10 minutes. But again, in the latest version of Work Manager, there is support for long-running workers, which means this is Work Manager's way of notifying the OS that this process is long-running. It will go beyond 10 minutes and should be kept alive if possible. The example can be bulk uploads or image processing algorithms. So now the Work Manager ensures that the support is there by running a foreground service on your behalf, and also provides the option of providing configurable notifications to keep the user informed as to what's happening. And so for that, in the new versions, we have APIs like set foreground, which works well with listenable worker, or the set foreground, which works well with coroutine workers, which is basically a developer's way of specifying that this task has a higher priority and needs to be kept alive. Now let's talk about actually a real case, real world scenario. So since I work for a ticketing company, we come across this scenario all the time. So let's say that a user is able to buy tickets to an event, and it selects the quantity, selects the event, then proceeds to the checkout page. Now, the user is also able to apply credits to the order, which obviously updates the checkout cost. Now, for some reason, the user leaves the checkout page before confirming the purchase. The order technically should be reset to release the credits and not make sure that the credits are available to the user at the same time. Now, each of these above steps actually needs a network API call, right? We have the save purchase, we have apply credits, and we have the reset purchase in case the user leaves the checkout page. Now, so basically the scenario here is that every time the user leaves the checkout page before actually purchasing it, we need to call this API called reset purchase in order to release these credits. Now, there might be a scenario where the user, this API is not called because there is no internet connection. So how Work Manager helps us to resolve this is by allowing us to schedule this task. And here you can see in the do work method, we are basically calling this, scheduling this API call called reset purchase, and also checking for ensuring that whenever we get the internet connection back, we need to ensure that this reset purchase is called and the credits are released. And if the response is successful, that's great. Even if it is not, then we allow it to specify a retry policy, because we want to ensure that the work is retried until it is successful. Now, there is another scenario. Let's say that on top of this, that reset purchase is scheduled by the work manager, but in the meantime, user reopens the app and also comes back to purchase. Now we need to ensure that the reset purchase is cancelled if there is a successful call to the Save Purchase API. So again, through the work manager, this is very easy, because all that you need to do is get that reset purchase by the tag and ensure that if the user, if the user comes back, then we can ensure that all the existing reset purchase tasks that are scheduled can be cancelled, and the user carries on with its own purchase. So basically, the whole idea is that the work manager allows you to handle these kinds of different scenarios and ensures that the work is done even when the user is not in a configurable condition, or if the user decides to exit the app, or the device restarts, or any other reason. So basically, conclusion is that work manager is super cool, and it is, again, reiterating all the reasons, is it allows backward compatibility, it supports one-time or recurring tasks, it supports complex chain of tasks with inputs and outputs automatically handled. It provides the ability to set constraints, so we know that the task will be carried out only when these constraints are met. It follows best health practices for the system and the optimizations, and at the end of it all, it still guarantees execution even if the app or the device restarts for some reason. So I think that's all from me. I am ready to take any questions.
Hi, Divya. I'm hoping you can hear me.
Yes, I can.
Okay, good. With all these crazy audio problems getting in, I had to log in over the phone. So, great presentation. I always think, as again, when I saw you in Boston in 2019 doing this similar presentation, I think one of the feedback that I heard from a lot of people is they very much appreciate how you make sure you let people know, particularly with what you're speaking on, when it's useful, when it's not useful, and also showing us kind of the power about grouping different tasks, chaining and things. So this was great to have you back again. I really appreciated you being here, especially on the short notice that we gave you this time. So you're always fantastic, though. Thank you. I'm going to get, Uli has already put Slido on the screen. We've got about 15 minutes, so I'm going to let you dive into the questions because we got people eagerly awaiting.
Awesome. Okay, so does it fulfill the work request even if we clear app data? I believe yes, but I'm not 100% sure. I'll make sure that I post a follow-up on Twitter about this, because I know that it uses the internal SQLite database to basically preserve the app states and the different states in which the task is there. But I think I will definitely post a follow-up on that. The next question, does the system notify when the work starts? It depends on the priority of the task, and I believe that with the new work manager, it is possible to configure these notifications and basically observe the progress of the work, observe the status of the work, and allow us to notify the user by getting the work info live data object and ensuring that you as a developer are able to configure that notifications and keep the user informed as to what the status of the work is. How can we effectively run Work Manager even after device was rebooted, and what about waking up a device that is off? So I believe the answer to this question is, so even if we provide the necessary conditions, and if we I don't think we can manually run Work Manager, but basically with the way Work Manager allows us to provide like different configurations. So you as a developer need to just like specify the task and the conditions, and the Work Manager will ensure that the task is carried out even if the device restarts, unless like obviously if the constraints are met, and also if it is beneficial to like the system optimizations. There is no harm to the system optimizations. Can I run a Work Manager forever? Something like scheduled polling. Interesting question. Yes, I believe you can, because unless and until you explicitly cancel the tasks, I believe you can run a Work Manager forever. But there is a guarantee that the work will be carried out. There is not a guarantee as to when, though, because again, it depends on the system optimizations. It depends on what the OS thinks is the higher priority tasks to be carried out. Can we use a precondition like for when permission is granted or revoked? I believe, I'm not sure about this one. I believe I'm not sure if there is a way to specify that as a constraint, but I'll definitely check out on this one too and make sure that this is answered as a follow-up on Twitter. How can a user cancel a task? Is there some kind of notification to let the user cancel the background task? Yes, there is. So basically, in your app, you can provide a way for, since you're sort of updating the progress and through configurable notifications to the user, you can, for example, you can provide a button which, or you can provide some way of user to respond to the notification, and and then in the app code just handle that user action to actually call the method cancel by the tag or by name, etc., to cancel the task that is going on. So this is all about ensuring that you are observing the task status at every time and ensuring that the user is informed of what the current status is. I tried the periodic Work Manager to work every 2 hours, but when it the first time to open the app, it launches the Work Manager right away. So that depends on if you specified any constraints or not, because as I mentioned earlier, so if there is no specific constraints specified for the Work Manager, then most of the time it immediately enqueues the task and the app launches the Work Manager right away. So in order to overcome this, there are 2 ways. A, you set the initial delay, which will ensure that the first time the task is carried out, it is only after that initial delay. And the second one is the on-demand initialization of the Work Manager that I talked about, which lets you basically ensure that the Work Manager is not launched, but only when you need it to be. What are the different kinds of workers available? Can we extend and create a custom worker? If yes, how? So yes, there is a way to, so the different kinds of workers is, there is a coroutine worker which works well with coroutines. There is a the GCM network manager, consistent one. There is one which is compatible with RX Java. So there are a bunch of them around here. And I also believe, yes, there is a possibility to create a custom worker to carry out a specific task. I can point as a follow-up on Twitter, I'll provide the link to how you can, there is a pretty good documentation around how to create custom workers. So I'll definitely point to that. Can we schedule a new task from within a currently running task? I believe you can through chaining, or even, again, it depends on whether we want that new task to be dependent on, if the new task is dependent on the current task. So if that can be done through chaining or by specifying new conditions. and that's what I feel might happen. Not 100% sure. Can the work manager be used in every use case for which the sync adapter framework has been used until now? That's a great question. I think I believe yes, but again, I would definitely ask all the questions that if the use case requires the task to be deferrable, if it is asynchronous, if it doesn't need to be carried out at a specific time. So I think if you answer all those questions and go step by step, then you can then every use case can be determined to whether it's the work manager is the solution or you need to use something else. Is it a good idea to trigger a work manager to make a background API request remotely? Again, it is dependent on how you're using the background API request response, because if we want for a lot of use cases, usually the response is what we are dependent on in order to carry out further execution. So for that, definitely work manager is not the solution. But if it is a deferrable response that we need only in the background for some reason, then I believe yes, work manager is the right solution. Which one is better, periodic or one-time request? If I have to upload a list of image on server by taking the list of image, again, it depends on how do we need to frequently upload these list of images on server, and depends on the use case. Because, for example, if we know that this is only a one-time push to the server for a list of images in one bulk, then obviously one-time request is better. But if we need to, if the use case is we need to constantly, periodically upload these images, then periodic one works better. Why can't we use set exact in work manager? I am not sure what set exact does, but I'm assuming it is something to do with setting it at an exact time interval or something. And I believe the answer is deferrable, but again, I can go back and check what set exact is used for and then follow up on why it cannot be used. Which worker should I use for polling? Also, how should I post all the data to the UI? Yes, live data would be the way to go. Basically, live data is easily configurable to the live data is easily configurable to get all the data and handle it the way you want. Which worker should I use for polling? So if you're writing code, if your code is 100% Kotlin, I would definitely recommend the coroutine worker, because that that's what I've been using, and I think it provides a very configurable yet efficient way of handling. But again, I would say it depends on the kind of use case and the kind of code that you're trying to write. So I am available on Twitter, always down for a chat. So DM me or tweet, and I can always provide follow-up answers in case I know I was not able to answer a bunch of them. So please reach out to me on Twitter anytime. I believe that's it.
Great. Divya, thank you so much for being here with us again. It's always wonderful to have you speak. Thanks again also to Ash. Ash, if you're still around, you can join your screen as well to us, and we'll say goodbye to you as well. Thanks again. If you'll see, we have coming up, oh, there's Ash. Well, there's a black screen. No Ash, but he's not there. There you go. Okay. We're still not seeing you, but no worries. Any case, so thanks again, both of you, for being here. Coming up on June 18th, we have our next hands-on in-depth series as kind of a bonus. The next one is June 25th as well. A couple of great speakers coming up. So we look forward to seeing you all back here again on the 18th and on the 25th. And again, Divya and Ash, thank you so much, and we'll be seeing you again soon, hopefully.
Awesome.
All right,
Thanks for having us. Oh, now
there you go.
yeah.
All right, there's that. All right, you all have a great day. Thanks again for everyone who joined in today, and we'll see you soon. Bye-bye.
Thank
Thanks,
you.
everyone. Bye.